Okay, let's have a look here. We've got a circle and we need to write down the coordinates of the center and the length of the radius. So let's complete the square. That's going to be x plus 4 squared plus y minus 5 squared equals, so that's needs to have a minus 16, that needs to have a minus 25, and there's a plus 32 there. X squared plus 8x plus 16 needs a minus 16, plus y squared minus 10y needs a minus 25. It's only one, isn't it? Because that's equal to 16 plus 25 minus 32. 25, 35, 35, and 6. 41 minus 32. So that's 9. So that's 3 squared. So a quick sketch. 1, 2, 3, 4. 1, 2, 3, 4, 5. That's about there. Yeah, so it's kind of run out of space, but you know, something like that. Anyways, you can mark it in, do a little bit of a nicer job. That's circle H. K is a circle having its center on the y-axis. So somewhere on the y-axis here, and x minus y plus 6 is a common chord of H and K. So that circle is y equals x plus 6. So like here. So yeah, so that's like the line there. So there's some point here where this can be a common chord. So we'll just say the other circle, we'll have x squared plus y squared plus 8x minus 10y plus 32, and then the second circle would have to be x squared plus y squared, and when I subtract it to make the common chord, I'm supposed to have x left, so that'll be 7x, and I'll have to have a minus 9 here, because minus 10 minus minus 9 is minus 1, and then I'll have to have a plus 6, so that would be a 26. I think that would do the job. They cancel. 8 minus 7 is 1x. Minus 10 minus minus 9 is minus y. And then 32 minus 26 is 6. So actually that seems to be the equation. But does that have its center on the y-axis? I don't think so. So I found a second circle, but I don't think it's quite the right one. K is a circle having its center on the y-axis. So that means if it centers on the y-axis, it shouldn't have a y coefficient, right? So let's think about this. Interesting. Oh no, it shouldn't have an x. So okay. So then if it doesn't have an x, So this will have to be a 0x. So when I subtract, they're gone, and that will be 8x. This here will have to be 8y. So let's think about this. How could I make an 8y there? So that would have to be minus 2y. So that subtract that, and that gets minus 8y. So I'll have to divide by 8 in a moment to get okay. So 48. So I think it's 16. So if I divide by 8, I'll get x minus y plus 6 equals 0. So I think this must be the equation of the circle, because it'll have a center on the y-axis. It can be written as x minus 0 squared plus y minus 1 squared. So that's x squared plus 0x plus 0 plus y squared minus 2y plus 1. I'll need a minus 1 here. Minus 1. And then, so minus 17. So equals 17 then. I think that's it. Although I could have just left it in this form. I don't know if I need to know the center and the radius. Let's have a look. No, I don't. So I can just leave it. I'll just leave it in the previous form here. So it's actually a short question, but I really have to think about how to do it. So that's the equation of the line. Because if you subtract those two, you'll get 8x minus 8y plus 48, and divide by 8. It does make the common chord. And because the coefficient of x is 0, it means it has its center on the y-axis. Good. Okay. If x is the axial symmetry of the plane in the y-axis, find the coordinates of the point of intersection of FH and FK. Okay. Maybe I do need the center now. So 0, 1. So that would be here. And then the radius would be 17, root 17. So look, something kind of roughly like that. Okay, if x is the axial symmetry of the plane in the y-axis, find the coordinates of the point of intersection of FH and FK. I'm not sure why we need the F here. F is the axial symmetry of the plane in the y-axis. It just seems to be an extra step. Find the coordinates of the points of intersection of FH and FK. So this is only going to get flipped over, so I'm not quite sure what the point of having that F in is. So we just need to find out where these two intersect. Okay, let's do that now. So I think the easiest thing here to do will be to sub the common chord into the second equation, because we can say x equals y minus 6 and sub that in. So we'll get y squared minus 12y plus 36 minus 2y minus 16 equals 0. So that's y squared minus 14y plus 20 equals 0. 16, 25, 2 and 10 doesn't do it. Let's get a calculator out. It has surd roots, which could be right, but let's just double check. So x is y minus 6, so x squared will be y squared minus 12y plus 36. and then minus 2y minus 16. So that's definitely minus 14, and then definitely 20. So I'm not satisfied that there's surds here. So we've got for y, seven plus root 29, and then 7 minus root 29. And then x is y minus 6. So if you just subtract 6 from these, that's 1 plus root 29 and 1 minus root 29. But that's these 2 points here. And the f is axial symmetry in the y-axis, so it's going to move it over to the other side. So basically the x's get negated, they become negatives. So I think the answer is going to be minus and minus here, and then minus and plus here. Yeah, I'm not 100% satisfied, but I guess one way I could check is I could check that that 7 plus root 29 is on the other circle. So let's just check that. 7 plus root 29. Okay, so that plus 4 squared plus that minus 5 squared, does that equal 9? No, it doesn't. So it means I've made a mistake, sadly. Let's check. Oh, yes, actually, I just didn't sub in the correct x. Sorry, let's try that again. Okay, x. So originally it was 1 plus root 29 squared plus y, which is 7 plus root 29 squared. Does that equal 9? No. No, it doesn't equal 9. It's way too big. Way too big. So there's something gone wrong here.